Okay, 8-126, do college athletes earn more? So at 2005, a 2005 study at the State University of New York looked at college athletes' earnings, meaning how much money they made, 6 years after graduation to determine if college athletes tended to earn more in their full-time jobs than non-athletes. The data is below. So you have the data in your table, in your textbook as well, and I copied it down here. We're going to look at number 1. Which data representation would best show this data? A histogram or a box plot? Why? Create the data representation of your choice for each data set. That is, make one for non-athletes and make one for athletes. Okay, so it's not asking us. So it's asking us to make sure we have 2 data representations, one for the non-athletes and one for the athletes. So let's take a look at the, let's answer the first question. Which data representation would best show this data, a histogram or a box plot? And if you guys are watching this video, you guys can see that I've set up histograms, and I think both box plots and histograms would tell the story. It would be able to let us know, where the data is spread, where it's skewed, and things like that. So both of them would work in this situation, but I think since they set up the intervals for us already, we'll go ahead and use that because it's set up for us. So this top one, let's go ahead and say that this is for the non-athletes. Okay, so for the non-athletes, okay, so 11 non-athletes make 0 to 27,000 a year. So I've set up the intervals or the bin sizes according to the tables, up to 27, up to 54, up to 81. So up to 27, up to 54, up to 81, and so forth. So for the first interval, they tell us there are 11 non-athletes. So they actually tell us the frequency already. Remember, histograms need frequency, so they already told us the frequency. So there were 11 here. Between 27 and 54, there were 9. Between 54 to 81, there was 28. Between 81 and 108, there's 26. Between 108 and 135, there's 16. Oops, let's label that. There's 16. So next one, between 135 and 162, there's 6. Between 189 and 216. I'm sorry, we skipped one. Between 162 and 189, there's 2. And for the last 2 intervals, there's 1 each. 1 and 1. Okay? So that's the first one. And this is for the non-athletes. We're going to look at the athletes next in the histogram below. Okay? Okay, and for the sake of time, I fast-forwarded. And this is the histogram. Oops, I forgot to label this. This is for the college athletes. These are the athletes' pay. And I'm actually going to go ahead and copy the top frequent histogram over so we can easily compare the two. Let's see, how would I do this? Okay, so we have the athletes and the non-athletes. The non-athletes are on the right side, the athletes are on the left side. Okay, so now that we have the histograms, we could start making comparisons and making starting to analyze the data, and we'll really be able to see the story and answer the question whether the college athletes make more or not. So number 2 is asking us what's the number of observations for each set of data, athletes and non-athletes. Well, to do that, we just add up the frequency, right? We could look at the histograms, but here they already set up the table. So we'll just go ahead and add up all the data. So I'm just gonna write right here. It's gonna be a little sloppy, but I'm just gonna go ahead and write right here. 11 plus 9 is 20. 20 plus 28 is going to be 48. Plus 26 would be 74. Plus 16 would be 90. And I know it's plus 8, 9, 10 more. So this is actually going to be 100 people, 100 observations. So I know because I did the math, I added the other side also earlier, and both sides will have 100. So there are 100 observations for each set of data. Okay. So someone can be considered wealthy if he or she makes $216,000 or more per year. What percentage of non-athletes make 216,000? What percentage of athletes make over 216,000? So we're looking at the athletes and the non-athletes. Okay. So 1 out of 100 athletes. Non-athletes, I'll put NA, and for the athletes, also 1 out of 100. So 1% of athletes and 1% of non-athletes make over $216,000 a year. Okay. So looking at our data representation, we need to, we're going to determine an estimate. So it does not have to be exact, but we're going to estimate, and we're going to see, well, what's the median or the middle salary for both the non-athletes and the athletes as well. So what would the median salary be? Okay, so I'm going to take a look at the data. So let's take a look at the data. And, well, we know the median should be somewhere around, the 50th person, right? So 7 plus 8 is 15, plus 25 is 40. So that must mean that for the athletes, they have to be somewhere in this bin. So that would make it between 81,000 and 108,000. And so let's go ahead and take a look at the next one. 11 plus 9 is 20. Plus 28 is 48. So it would also be somewhere in the 81 to 108,000 range. So the median salary is going to be between 81,000 and 108,000. That would be the median salary. So we're looking at the data. Okay, so the median salary for both athletes and non-athletes is between 81 to 108,000. Okay. So now we could, again, they're asking about the typical athletes and typical non-athletes. Well, we talked about how typical really just means the median. So we could say the typical athlete and non-athlete earns the same. The typical athlete and non-athlete earns around $81 to $108,000. Okay, so now we have to answer this question: do college athletes earn more after graduation than non-athletes? We have to justify our answer by comparing the distributions as completely as possible. We're going to talk about the 4 things. Okay, center, shape, typical range, and outlier. Okay. So as far as center goes, well, center. Let's take a look at the center again. The center means mean or median. So where is it? Mean or median. So we figured that the center, the median salary is between 81 and 108,000. So center, that's mean or median, and that's going to be roughly, we'll just go and put in the low end, roughly $90,000. That's center. The shape, if we look, it looks, I would say this is symmetric, or actually no, I would say it's skewed to the right. If we notice, we could somewhat see that most of the data is here, and then at the end it starts coming off. And same as before, most of the data is here, at the end it starts falling off. Okay, so I'm going to say this is skewed to the right. Okay. Okay, and both of them are similar in that regard. They're both skewed to the right. Okay, the typical range. Okay, the typical range. Okay, so I was wondering where in the question they helped us, or they had us answer this, and I realized in number 5 I didn't completely answer the question. So we're going to take a look at number 5 again. It's asking, between which salaries do typical athletes earn? So it says between, not what is the typical salary, between which salaries. So that's where the range was supposed to be. Excuse me. So if we notice, it's the typical salary, most of the people are between 54 and up to 135,000. That's actually for both. If we look here, between 54 and 135,000. So I'm going to change my answer here. So the typical athlete and non-athlete earns, earns between $54,000 and $135,000 a year. Okay, so that's going to be the typical range. Okay, so the range is 54 to 135,000. And were there any outliers? I don't think there are any outliers, so we're going to say no outliers. Okay. All right, so let's compare our distribution. Well, center is the same. The median. I'm sorry. We only calculated the median. The median was about 90,000. So the center is the same. The shape, they're both skewed to the right. So that's the same. The range are both the same. And there are no outliers. So what conclusion can we make? Okay, if we had to do say, show, so, I know the book doesn't say that, but say, well, I think I'm going to have to say that the college athletes do not earn more. Money. Okay, college athletes do not earn more money. We can't say that because it seems like everything's the same. And the show, we had a lot of, we showed how we found the median, we showed how we found the shape and the range. So I'm just going to abbreviate and say the center, shape, and range are all similar. I don't want to say they're exactly the same because they were not. The data was slightly different, but for the most part, it's similar. So because center, shape, and range are all similar, we can say their pay is the same. Okay, so based on the shape of these data sets, which would be a better measure of center, mean or median? Okay, so we talked about how it was skewed, the shape was skewed. So remember, if the shape is skewed, median is the better measure. So median is a better measure of central tendency because the shape is skewed.